Welcome to Inequalities and their graphs. There are 10 boxes in this lesson. The essential understanding of inequalities and their graphs is as follows. An inequality is a sentence that uses an inequality symbol to compare the values of two expressions. That's the official definition of what an inequality is and does. So let's get right into it here. Here is box number 1. And in case you are unfamiliar or can't remember the inequality symbols, I wrote them down for you right here. We're going to go talk about them. This symbol means less than. And an example is 3 is less than 5. That's just a true statement. The next symbol is less than or equal to, as denoted by the line underneath it. And an example is 3 is less than or equal to 3, because 3 is equal to 3. So that's a true statement still. If the arrow is pointing to the right, we have a greater than. And an example means 10 is greater than 9. Pretty straightforward. If it's greater than or equal to, then I could say that 20 is greater than or equal to 20 because it's still a true statement. And then there is not equal to, which is one that students sometimes forget, and we can always say that as an example if 7 is not equal to 2. In box 2, I'm going to show you 4 examples of how to write an inequality. So part A says all real numbers x less than or equal to negative 7. So I would simply say x has to be less than or equal to negative 7. That is an inequality statement. Part B says 6 less than a number k is greater than 13. So 6 less than a number k. So if I start with the number k and I subtract 6, that quantity right here, this represents 6 less than a number k. Okay, that whole entire expression is 6 is less than a number k. And then I want is greater than the number 13. So this is how I would write that inequality. Part C, all real numbers p greater than or equal to 1.5. So I would say p greater than or equal to 1.5. You'll notice that in all of these examples, I like to keep the variable on the left-hand side of the inequality. It's very useful. Box number 3 is a U-try. I'd like you to write the inequality. The sum of t and 7 is less than negative 3. Here is the solution. The sum of t and 7, so that would be t plus 7. That right there represents the sum of t and 7 is less than negative 3. Box number 4 is a definition. And when we're talking about the solution of an inequality, we're talking about any number that makes the inequality true. And there is an infinite amount of them. So as an example, this statement says x is less than 5. Can you think of any number that's less than 5? Well, of course you can. There's so many of them. 4 is less than 5, so x could be 4. 3 is less than 5, so x could be 3. 2.8 is less than 5, so x could be 2.8. As you could see, we could be here all day creating a bunch of solutions for this one little inequality. So we're talking about any number that makes the inequality true is a solution. Box number 5, we're going to identify a solution. So here's an example. Let's say we were given 2x plus 1 is greater than negative 3. Are the following values of x a solution? Let's test x is equal to negative 3. So I would plug in. So I'd go 2 times negative 3 plus 1. Is that greater than negative 3? 2 times negative 3 is negative 6. plus 1, is that greater than negative 3? Negative 6 plus 1 is a value of negative 5. Is negative 5 bigger than negative 3? Unfortunately, no, it is not. Negative 3 is closer to 0, therefore negative 3 would be bigger. So negative 5 is not. So x equals negative 3, this is not a solution because we got a false statement and we are looking for a true statement. Let's take a look at this one. Negative 1. 2 times negative 1 plus 1, is that greater than negative 3? 2 times negative 1, that's negative 2. Negative 2 plus 1, is that greater than negative 3? Negative 2 plus 1 is negative 1. Is that greater than negative 3? And the answer is yes, because negative 1 is closer to 0 than negative 3 is. Therefore, it is greater than negative 3. So therefore, x equals 1 is a solution. Is a solution. Box number 6 is a U-try. Consider the following numbers: negative 1, 0, 1, and 3. Which of them are solutions of the inequality 13 minus 7y is less than or equal to 6? Here is the solution. I plugged in each value given to me. Negative 1, I plugged in here, and I got a false statement because 20 is not less than or equal to 6. I plugged in 0 and got a false statement because 13 is not less than or equal to 6. I plugged in 1 and I got a true statement. 6 is less than or equal to 6. So therefore, 1 is a solution. So this is a solution. Similarly, I plugged in 3 and got negative 8 is less than or equal to 6. And that's also a true statement. So therefore, 3 is also a solution. Box number 7 is learning how to graph an inequality on a number line. And I'm going to teach you how to do this. I have 4 examples. Example A says x is greater than negative 4. Here is how you do it. You draw a number line with arrows on both sides indicating that the line goes on forever. You give me 0 on the number line. It doesn't matter where it is. You have to give me 0. Then you have to give me the point in question. And the point in question for example A is negative 4. Negative 4 is to the left of 0 on the number line, and that needs to be accurate. Once you got that down, you're going to say, okay, I want all numbers that are bigger than negative 4. So I draw an open circle and I draw my graph to the right and I shade to the right because I want to make sure I'm getting all values that are bigger than negative 4. And if you want to check, just pick any value in this interval and check it. Say if like 3. Is 3 bigger than negative 4? Yep, it sure is. You must have done it right. Let's do example B together. R is less than 0. Again, draw your number line. Give me 0. And in this case, the point in question is 0. And it is strictly less than 0, so I do not include it. So I have an open dot and I shade to the left. So it would look like this. Take a look at example C. Example C says 3 is less than or equal to t. Now this one's a little bit tricky. The reason this one is a little bit tricky is because the variable is on the left or is on the right hand side, and I prefer my variables on the left hand side. So if 3 is less than or equal to a number, that means that the number is greater than or equal to 3. So think about it. 3 is definitely less than or equal to 30. And that means that 30 is definitely bigger than or equal to 3. They are equivalent statements. So I would prefer to have my variable on the left. The reason is just about what I'm about to show you. Give me 0. Give me 3 to the right of 0 because 3 is to the right of 0 on the number line. You're now going to give me a closed dot above the 3 and shade in the direction of greater than, which is the same direction that the arrow points. So if your variable is on the left of your expression, the inequality sign will always point in the direction you shade. If it's not, it'll be the opposite. Last example. -5 is greater than or equal to m. Well, I would prefer to write it as m is less than or equal to -5. Equivalent statements, I prefer to read it that way. So again, give me your number line, give me 0, give me -5, and I want everything that is to the left of -5, including -5, so I'll close in my dot and go to the left. And I would shade everything to the left. Box 8, we're going to do the reverse. We're going to look at a graph, and we're going to write the inequality. So for part A, we want all numbers that are greater than or equal to 3. So I'm going to say that x is greater than or equal to 3. You could have also said this, 3 is less than or equal to any x that you pick. I would prefer you to use this one. However, either one of these is correct. Part B, that says, I'm going to choose the variable x. This says that x is less than -4. Or you could say that -4 is bigger than any x that you pick, but again, I would prefer you to use this one so we're all speaking the same language. Part C, this says that x is greater than 7. And part D, this one would say x is less than or equal to -3. Here's an example where you might see an inequality in the real world. Look at this poor little kid. I don't think he's going to make it. You need a minimum height requirement of 42 inches. So if I let h equal the height requirement, then the inequality that I could say is h must be greater than or equal to 42 inches in order to ride the ride. I don't think he's going to make it. Better luck next time, kid. Last box is a you try. If I define the variable for you as s, let s equal the speed limit, how could you write an inequality that would reflect this speed limit sign? Hopefully you saw that s needs to be less than or equal to 70 miles per hour. Otherwise, you could get a ticket.